All right, our next presenter is Jacob Manzi from Boise State University.
Our electronics are constantly improving, changing, and sometimes in need of repair. What do you do when your electronics break down, when your phone needs a new antenna, battery, or screen? You probably take it to the Geek Squad or the Apple Genius Bar, right? Or maybe the more adventurous and tech-savvy among us take a trip to Radio Shack or order the parts you need to do a DIY repair or upgrade. Now, put on your space helmets and picture us as a civilization living 50 years in the future, on the moon, Mars, or somewhere else. There's no Best Buy or Radio Shack to make sure your iPhone or TV remote are in working order. Plus, it costs about $10,000 per pound sent into space, so I don't think Amazon Prime will ship to you either. My research is in developing a novel technology called plasma jet printing. Uniquely, this printer uses a small jet of plasma to spray nanomaterials onto a substrate and make what we call a printed electronic. In the figure on the left, you can see the black flecks are the nanomaterial being passed down through the purple plasma and onto the flexible yellow substrate below. The inset shows one version of the printer that we built on campus that you can clearly see the purple plasma beam coming out to the side. Now, there are other printers that can print materials, such as inkjet or aerosol jet printing, but they all require a post-processing step, usually involving high heat or intense UV light. These steps are costly, but crucial for the functionality of the printed devices. They also limit what substrates can be printed on, as they need to be able to withstand this high heat treatment. Now, because of the plasma in my setup, there's no need for post-processing, as the materials come out of the printer fully functional and ready to use. The plasma also doesn't burn or melt the substrate, so even paper and thin plastic can be printed on where they couldn't before. The plasma also makes it so that printing is independent of gravity, and a group recently showed on a zero-G flight that the plasma jet printer works in space and microgravity environments and can even print in any direction. Now, during my time at Boise State, I've printed parts for flexible thermoelectric generators, a device that converts thermal energy into electricity. Think of it as something that might charge your Apple Watch using the heat of your body. I've also printed flexible and conductive silver and gold wires, and I'm working toward printing a functional antenna, as well as strain and optical sensing devices. This research is contributing to the ability to be able to print multiple materials onto one flexible and conductive substrate, like the one the astronaut is holding in this image on the right. Thankfully, this technology won't be for a civilization 50 years in the future, but functional in the next several years for both astronauts and civilians to be able to print flexible batteries, solar cells, biosensors for health and fitness monitoring, and more. Thank you.
Thank you, Jacob. That's like science fiction a little bit when I hear it. So you talk about printing batteries. I sort of have a hard time getting my arms around that, although, given all the waste we have with batteries that we use up and everything. So how does that work?
Yeah, so essentially you could find all of the materials that make up a battery and be able to print them instead of like encased and like rolled up inside of like a D-cell battery that we have, but be able to print them on like a flat substrate or do the same thing as long as you can get the materials into ink form.
The heat form. What's your major?
I'm an electrical computer engineering major.
Okay, and where are you from originally?
I'm from Monmouth, Oregon, just outside of Salem.
Okay, well, thank you. Good job.
Yeah, thank you very much.